In the autoregressive framework, we used information criteria to find the optimal lag selection. And the number of lags, the values for P and Q and through QK for the different variables, we can use the same approach as we used for the autoregressive model. And the first one we looked at was the F-statistic approach. And as in the autoregressive models, we can use we can calculate the F-statistic to test whether a coefficient is equal to 0. And remember that the F-statistic is just the square of the t-statistic, which means that if we have a beta hat and the standard error of the coefficient estimate, then we just square it and get the F statistic, which means that the t-stat and the f-stat they use different tables, but they will yield the same results nonetheless. However, as you probably remember, the f-stat or the f-statistic approach, it tends to yield a too large number of lags in your model, because you're supposed to start off with a large model and then you test the last lag, and if it's statistically significantly different from 0, then you keep that lag and all the smaller lags in the model. But sometimes just by statistical fluke, then you are going to keep a non-important lag in the model, and then automatically you keep all the lower lags in the model as well, and you don't get to test those shorter lags. As with the autoregressive model, we can use Bayesian information criteria and the Akaike information criteria to determine the number of lags in the model. And let's say that the model has k coefficients, and that is actually the number of coefficients on the y variable and the number of lags for the first x variable and the second x variable, and so on until x small k t minus 1 and their last lag t minus p, for example, and down here. And so you see that in addition to the intercept, you might have a lot of coefficients in the model. And but as always, you use for example, the Bayesian information criteria for p lags. You just calculate the sum of squared residuals of the regression model divided by the number of observations, which is capital T, plus the number of coefficients time this log t divided by t term. And it's best to have a as low as possible value, and that's why you test several lags or several lag lengths, and you choose the model which provides the lowest value of the Bayesian information criteria, or the archaic information criteria. 2 points about the Bayesian information criteria and the archaic information criteria are that with the use or as we saw with the autoregressive model, all the candidate models should be estimated using the same sample. So even if you have a model which do not have many lags and thus could have used more of the data sample that you have, then if you are comparing this with a model with more lags which cannot use as much of the data sample, you have to make sure that both models use the same sample, which means that they use the same number of observations to calculate the Bayesian information criteria and the archaic information criteria. And if you have a lot of X variables, then you might end up with a lot of different combinations of lags. So to make this procedure more easy, then you set all the lag lengths equal to each other. This just means that the lag length of the y variable is until y t minus p, and the lag lengths of the x variables, they are also to the t minus p lag, and this is equal for all the variables. This means that you don't need to calculate or estimate as many models to find the optimal lag length with the Bayesian and the archaic information criteria.